Hi there, in this video clip I'd like to talk about the electronic structure of atoms, and the electronic structure determines the position these elements are found in the periodic table. I've said previously that a simple picture of the atom consists of a nucleus, contains neutrons and protons, and around it electrons are found around the atom. However, these electrons move in orbits, but all these orbits are not of the same energy, and these are found in shells, electron shells, like so. These shells can only contain a certain number of electrons. The first shell can only contain 2 electrons. The second shell can contain 8 electrons. And the third shell can also contain only 8 electrons. So if I said something contains, let's say, 10 electrons, it means therefore that the first shell, that's that shell, can only contain 2 electrons. So 2 from 10 is 8. It means that the next shell can contain 8 electrons, and to make it simple, let's draw them in pairs of electrons. So something's got an atomic number of 10. Its structure is 2, 8. Let's look at some more examples. Let's take chlorine. Chlorine. It's got 17 electrons. Let's draw the shells. There's a nucleus, 2. Let's draw its electronic configuration. 17. First shell can contain 2. I'm going to put a comma in there. Next one can contain 8, which is 10, and I'm left with 7 electrons in the outer shell. Let's take another example. What is the electronic configuration of silicon? So silicon, atomic number 20. The first shell contains 2. The second shell contains 8. That's 10 so far. The third shell can contain 8, which leaves 2. So its structure would be 2, 8, 8, 2. I've said this in a previous video clip that the periodic table, a very, very simple one, looked a bit like this. That was hydrogen, that was helium, and I said it contains 8 groups. That's 1, 2, 3, 4, 5, 6, 7, 8. So, elements found in group 1 contain 1 electron in the outer shell. Elements found in group 2, let's number them up. 1, 2, 3, 4, 5, 6, 7, 8. Elements found in group 4 have 4 electrons in their outer shell. Elements found in group 1 have 1 electron in their outer shell. And it's the number of electrons in the outer shell that determines the chemical properties. A long time ago, Dmitri Mendeleev, what he did was he started to do work on the periodic table, and he arranged these elements according to their atomic weight, their atomic mass. By the way, they hadn't even done the work on protons, neutrons and electrons. What he did was he weighed things and compared them to hydrogen, and he said hydrogen has got an atomic weight of 1. Let's compare the weight of all of these elements compared to hydrogen. When he did this, he got a table, so we'd get elements in groups or with similar chemical properties, so he arranged them according to their atomic weight. However, life was not smooth, and he found it didn't work that way in particular, and there were elements coming out being found every day. So what he found was he left spaces or gaps, and these spaces or gaps, a block of them in the periodic table, are called the transition elements or metals. I want now to look a little bit into electronic configurations. Let's look at sodium. Sodium is found in group 1 because it's got 1 electron in the outer shell. Chlorine is found in group 7 because it's got 1 electron in its outer shell. Let's look at sodium. Na, symbol Na. It's got an atomic number of 11. So therefore its electronic configuration would be 2, 8, 1. How does sodium form compounds? It's got that 1 electron in its outer shell. So therefore, when it wants to form compounds, it needs to lose 1 electron. Calcium found in group 2. It's got 2 electrons in its outer shell, so therefore when it forms compounds it has to lose 2 electrons. Aluminium, group 3, has to lose 3. I've been speaking there so far about the metals. Let's take sodium. It loses 1 electron in the outer shell, and it forms a sodium ion. It's lost a positive charge. It's lost an electron. Let's take calcium. In group 2, loses 2 electrons when it forms compounds. Aluminium, found in group 3, loses 3 electrons to form an aluminium ion. So when atoms lose or gain electrons, they form ions. Sodium forms a sodium ion, calcium a calcium ion, etc. These positive ions are called cations. Now, if you look at the periodic table, it starts with metals on the left hand side, and eventually going over we get, say, groups 7 and O or 8. You've got fluorine, chlorine, bromine, and in group 8 you've got helium, neon, etc. So we've gradually got a change from metals to non-metals. What's the difference between them? We'll come a little bit back to that later on, but I've said this: metals lose electrons and they form cations. Non-metals, oxygen, sulfur, etc., they gain electrons, so they lose electrons, and non-metals gain electrons to form negative ions, and these are called anions. It may seem difficult to start off with, but it's not. If I said to you this, metals, what's the properties of a metal? And let's put non-metals there. Take something, we haven't even spoken about the transition elements, but metals. Let's take copper. It's shiny. It can be drawn into a wire, ductile. The hard, the solids, they conduct two things. They conduct heat, excuse me, they conduct heat, and if things conduct heat, they generally conduct electricity as well. All of the properties of those metals is due to their electronic structure, and it must be something to do with what they contain inside of them. So the properties of metals, the solids, the hard, they conduct electricity, they can be bent, they're ductile, they're malleable, and they conduct electricity. Non-metals are insulators, poor conductors of electricity, they don't in fact, etc. So that is the difference between metals and non-metals. Later on I'll be going into specifically speaking about the properties of the elements found in group 1 and in group 7 and group 8. But the major thing you have to know is the properties, the chemical properties are related to the number of electrons found in the outer shell, because these electrons are either lost or gained in chemical reactions.